Hello friends, this is the theorem. Every non-singular idempotent matrix is an identity matrix. Here we have to prove that every non-singular idempotent matrix is an identity matrix. So first we see here what is given. So here given non-singular idempotent matrix. So let us suppose that let A be a non-singular idempotent matrix. Let us suppose that here we suppose capital A be a non-singular idempotent matrix. We know that non-singular means inverse of that matrix exists. Here A is non-singular, that means inverse of A matrix must exist. And idempotent matrix, that means square of A is equal to itself. So A be a non-singular idempotent matrix means A inverse exists and square of A, this is equal to A, because we know that if the matrix is non-singular, then inverse of that matrix exists. Here we suppose that A is non-singular, that means A inverse exists, and A is idempotent, that means square of A matrix is equal to itself. So by property of inverse, we know that A multiplied by A inverse or A inverse multiplied by A, this is equal to identity matrix. Now we taking A square is equal to A. We multiply by A inverse on both sides. So A square is equal to A because A is idempotent matrix. Now A square can be written as A multiplied by A, this is equal to A. Now multiplying by A inverse on both sides, you can see here A is given idempotent matrix, and we know that by the definition of idempotent matrix, square of every matrix is equal to itself. So A square can be written as A multiplied by A. So we multiply both the side by A inverse. So this can be written as A inverse AA is equal to A inverse A. Now we using here in the left hand side associative property. So by associative property we can write this A inverse A within bracket into A is equal to A inverse A. And also we know that from second equation A inverse A, this is equal to identity matrix. So IA is equal to I here. So when multiply A matrix by identity matrix, this gives A matrix, so A is equal to I. This shows that if A is non-singular idempotent matrix, so this is identity matrix. So this shows that every non-singular idempotent matrix is identity matrix. You can see here. So first we suppose that A be a non-singular idempotent matrix. We know that if A is non-singular, that means inverse of A matrix exists. So A inverse exists. And here A is idempotent matrix, so square of A matrix is equal to itself. We know that by the property of inverse, A multiplied by its inverse or A inverse multiplied by A matrix, we get identity matrix. Now A is idempotent, so we know that square of A is equal to A. A square can be written as A multiplied by A is equal to A. Now pre-multiplying by A inverse on both the sides, so we can write A inverse multiplied by A is equal to A inverse A. Here we using in the left hand side we using associative property, so this can be taken as A inverse A multiplied by A is equal to A inverse A. And by the definition of inverse, A inverse A is equal to identity matrix. So in the left and right both we write identity matrix. Now A matrix multiplied by identity matrix, this gives A matrix, this is equal to identity matrix. This shows that if A matrix is non-singular idempotent matrix, so this is an identity matrix. Thank you.